Hi. I'm John, and this is Nicolas. We work on Android. We worked on ConstraintLayout and the Android Studio design surface. So, take it away, Nicolas.
All right. Just as a little prelude, I'm going to talk about material design. So, you heard about it's a metaphor, it's paper, it's shadows, it's all of those cool things. But actually, as a developer, you probably don't care too much. It's also bold and full of colors, and well, just ask your designer to give you the right colors, right? That said, it also is really focused on motions, and that is more up our alley as programmers, because we do have to implement those motions that the designers want us to do. One key aspect is that motion provides meaning. It's not just gratuitous. You shouldn't just go and, bring up fireworks in your applications and jiggly widget and all of those things. It really should be tied to some kind of meaning. The point is really to have, and what they call it like intentional motion, but really the idea is that you try to be, clear in your UI so that you provide some help to the user. The point is that if you can have your user build a good mental model of how your application works through animations, well, they will make less mistakes, they will understand your application better. So it's a good principle. And another example from material design, if you click on this image, it just pops up, change everything, but you can see how everything ties together, that whatever information on that panel is going to be tied to that image. So motion really helps with meaning. Material designers also specify a beautiful baseline grid of 8 dp where you are supposed to align your elements, which is wonderfully easy to do with linear layout and all those great layouts. They also defined key lines. So key lines is, they call it like so many words. Grid lines, key lines, vertical rulers, red lines. So it's basically just vertical and horizontal lines, and they describe their UI in terms of those lines. This is all great, but in Android, we don't really have anything to help with that. And they also talked about ratio, which, it's again, there was nothing specific in the framework to help with that. But you can see that it does help. It can really help building really nice UIs, and all of that is from this website that goes and do a great overview about the material design concepts, and they go into way more details than what I just went. But just to give you a little prelude of this is what we need to do now as developers. If you want to build a modern application on Android, that's the bar. And to build those UI, well, the Android framework try to help you a little and build various components that you can use. The first thing that I can talk about is layouts. That's in some ways that's the basic stuff, right? If I have stuff on screen, I need to be able to decide where to put them. And traditionally, we can distinguish between simple layouts and complex layouts. The simple ones you should really know well, like linear layout and frame layout and stuff like that. The more complex one, grid layout, relative layout, and constraint layout. Let me do a very quick review on constraint layout. Yuan did a fantastic talk this morning, so if you haven't seen it, I'm hoping you're watching right now from YouTube, and I would say stop everything, go watch the talk and come back. But for the one that did not see the talk this morning, let me very quickly recap a little bit of what is constraint layout. So one of the ideas we had was to make flat layouts. There is, and we've talked about the performance implications of that. Sure, but there is also other advantages. Particularly if it's flat, it's a lot easier to change. The one thing we wanted to do as well is to build like a layout that was very expressive, so that you could indeed create those flat layouts, and you can in a sense do any type of layout you want. And finally, from the very beginning, from the first prototype, we built a visual editor that was going along ConstraintLayout. And that's really a key difference between ConstraintLayout and other layouts, in that the editor helps ConstraintLayout, and vice versa, ConstraintLayout has specific features that help building a good UI builder. So, as a quick example, I promise I'll be fast. This is how you would typically build a UI, with existing layouts. A bunch of vertical layouts, linear layouts, horizontal linear layouts, one relative layout for, fancy overlapping stuff. And that's not even that crazy. It looks not that bad. It's a little deep, but not that horrible. I think it's very common to a lot of the UI you probably built. Believe me, I've seen worse. In ConstraintLayout, and one of the problems with nested hierarchy has to do with performances. So if this text view in red and decides to change its bounds, change its content, or whatever, it needs to be recomputed, remeasured. That will actually result into remeasuring all of those, just because it's a nested hierarchy and the way the system works. So I don't think it's so important anymore, particularly if you keep this type of this depth. It's not that bad, and it's not so important now with modern devices. But you can still very quickly end up in a situation that's not so great with very deep layout. So be careful. That's what I'm saying. With ConstraintLayout, of course, it's a lot simpler, right? Everything is flat. And this is how it looks with the different relations, the different constraints to set up this UI. It's a very small library. The idea was so that you really don't hesitate about pulling it and using it in your project. Remove one PNG and use the library, please. It's unbundled, which is good because for you, it means that you control what goes into our application or not. It's not provided by the framework, it's you decide. If you have a version of ConstraintLayout that works well for you, use that one, you can stick with it until the end of times. For us, it's great because that means that we are not, when we were working on framework, one of the problems is, we were working on this release really, really hard. And then, talking to developers and saying, look at these amazing features. And they were saying yeah, I'm going to look at it in 2 years. So we try to avoid that, and that's one of the reasons we did ConstraintLayout as a bundle library, and we took advantage of it, right? We released a lot of versions. It's based on very flexible foundation, like this linear system solver, but more importantly, the point of it was not so much to provide a system of equation and asking you to write mathematical equation to describe your layout. We instead devised this constraint system, this way of kind of providing those rules at a higher level than just in equations. And that's actually very important. One, I think it's clear. Two, it provides kind of a grammar for you to describe your UI. But also it allows us to optimize, to do some really interesting optimization passes, because we are thinking about the problem at a higher level than purely linear equations. And there is, of course, optimization at the solver level. And, as I said, we built it with the UI builder in mind, and also with the inference engine that John will talk a little bit about. Good thing being unbundled, tons of releases. About 16 since we announced it at Google I/O last year. It's 2 to 3 times faster, maybe more in some cases than what we announced. New features like chains, better visual editor support, and it's now since the 1.0 the default layout in Android Studio. What that simply means, don't worry, it just means that if you create a new screen, like a new activity using the templates in Android Studio, well, those templates are now using ConstraintLayout instead of relative layout. That's all. You are still in full control, no worries. Quick example, you have a row. This is how it will look with ConstraintLayout. I'm not going to go through the details. Again, plenty of amazing talks describing that. But basically everything is flat and you have a single hierarchy level. quick example on something a little more complicated. So you might have this type of situation with layouts where you have some text on the left and you want it to grow, but up until a certain limit. And you can do that now with some of the recent features we added. Basically, you can use a chain and mark that element that resized as match constraint. But the default for match constraint is to spread, to basically take as much space as it can. You can now decide to make it as wrap content. And it behaves like if it was wrap content, but it will still go against the constraint, which is very convenient. There was some questions earlier about the behavior when you mark a widget as being gone. And contrary to other layout systems, constraint layouts deal with that, no problems. We basically decide that if you mark a widget as being gone, we'll change its dimension to 0, and the connection, the margins of those connections will also be 0. So it kind of resolves to a single point. And in some cases like this one, it works beautifully, right? And I don't think you should build your entire UI to be based simply on toggling on and off gone objects. But still, for some small modification in your UI at runtime, that can be very convenient. Of course, no solution is perfect. If you do that on the first element, you end up with this, which completely follows the rules I just said. The button, resolved to 0, 0. The margins are also 0, so therefore everything goes to the left top corner, which may not be what you wanted. So what we have added is a concept of margin that will only be applied in those values if the target you are connected to, your constraint to, is marked as gone. And in that case, you can specify different margins to make sure that you stay there. So the second button, instead of having a margin on the top of 0, has now a margin of 32 if the first button is marked as gone. All right.
Okay. Frameworks and support lib. So we want to just give you a quick few of the built-in tools in support lib. The kind of things that you could also work with that are not using constraint layout or could use constraint layout inside of them. The first one is the navigation drawer. It essentially gives you a menu that pulls in and is the principal navigational element in material design. The next one is a view pager, which is basically our tabs. You go from left to right. This one is interesting in that you're seeing they're folding in a lot of animation on top of the transitions of just tabbing between the views. And those are very fascinating. Notice they're moving around a bunch of views to try and give you some information. And it's a good question of what they're trying to convey there, but I'll leave that to your imagination. And then another one is coordinator layout, and it has the pulling in from the bottom and bringing in from the top and the floating action bar, so that if that's exactly what you want to build, you can just use this. But know that they're very, very fixed things. That's just the way they work. You can put a button there. They have a few options, like you can toggle on other features or turn them off. You can not have a bottom menu or have one, but it's a canned look. And if your app doesn't want to do that canned thing, it's going to be a little difficult. So now,
Yep.
You talk about this one.
And actually, very, very briefly on the coordinator layout, the one thing I would add is it's actually really powerful. But if you do not want to use the embedded behaviors that are provided, you have to run your own, which is both really powerful and also quite a bit of work. So, on that note, Studio. Well, if you want to create a modern application, I sure hope you are using Android Studio right now. If you are still using Eclipse, come to see me. All right, so what were the goals for Android Studio? And more specifically, because that's the part we're working on, about the visual designer. Well, the visual designer is here to visualize. I know, shocker. But basically, the idea is that if you are dealing with layout, with a UI, it's kind of nice to be able to see what you are doing. And I know all of you are experts in XML. Still, having a visualization is great. And if we can avoid a round trip to the device, that's definitely better. Second thing, well, we want to provide you tools that let you easily create UI, right? It should be easy, should be also very efficient. The point is not to make tools just for the sake of making tools. We really want to make tools that are useful to you, and we really think we can make you a lot faster, a lot more efficient when dealing with UI. So, quick overview of Android Studio for the few in the room that haven't used it yet. You got like the palette, that's just a list of different widgets, components that you can drop in on your screen. You got a component tree. This one is actually interesting because you can think about it as a representation of your XML. It's the actual hierarchy that you have in your XML file, and you can use it to select stuff. There is a toolbar with a lot of interesting options that I'm going to cover very soon. And there is the design surface, which is the main view in Studio. And that lets you both visualize and interact with your design. Finally, there is the inspector that inspects and gives you the list of attributes of the view that you have selected. One thing that's interesting is, I showed you like this mode, and that's what we call the design mode. The idea for that is to show you the UI as it should look on your phone. But we also have this other mode that's called the blueprint mode. And here the goal is a bit different. The goal is not to show you exactly what it looks like, it's to show you all the information that are really useful when you are dealing with layouts, meaning the actual real bounds of your views. And in the case of ConstraintLayout in particular, we show you all the constraints, which is very convenient if you're trying to see what's going on. And you have different ways to toggle between showing only the constraint of the selected element, showing all the constraints, etc. So there is different visualization mode, but fundamentally it's here to show you what's going on. And you can have both. If you are really used to XML, you might be interested by this mode. You have a little button on the right side of the screen that toggles the preview panel. So you can actually edit your XML and have the UI being displayed there. This is actually not just a preview panel, it's a full-blown editor. You can edit stuff in the preview, it will modify the XML on the fly, and vice versa, if you modify the XML, it will show up in the preview. So if you really want to do stuff in XML, at least use the preview mode, it is very convenient. One thing that you may not know about is the tools attributes. Fundamentally, we have a problem, right? If you have a UI, beyond like a demo UI that just contains some random content that you just put together, it's very likely that at least part of your UI is going to come from your application. You are going to pull data from the network or from a file or whatever, and that's what you want to display. The problem is that in the designer, we don't know that. We don't particularly want to execute your code, no offense. And tools attributes allows us to specify a content that will only be used in the designer. So it kind of override the attributes during the design time. There's a couple that are pretty useful. So showing, for instance, if you're creating a layout that's a sub-layout of some kind, but you want to see it within the context of the layout it's included in, use showing. Layout, fragments are great. And so you can, add an attribute here to define which layout you want to display in place of the fragment. List item is very useful as well if you have a recycle view or a list view. You can specify the layout that you will use for the rows. And finally, if you're using merge tags, parent tag is your friend. It can help us decide what's the view handler we use, what's the interaction we provide for editing that particular layout. And all of that, you can find it on the page indicated on top. But yeah, look at it. And this is an example of the list item on Recycle View. You may know that, some may not. There's a couple of useful shortcuts. I mean, so many more than I can cover here, but at least for the designer, when you click on an element, we select the deepest one by default. Sometimes you want to play with the parents, so you may select it through the component tree, but simply pressing the escape key, select the parents. It's very convenient. And toggling between XML design mode, you can do that with Control-Shift, left or right. And finally, if you have included elements, which I think is very common when you create complex UIs, you can just double-click on them either in the component tree or the design surface, and that will go to the file. So, and that's something I think we can do better as well. We'll improve, but it's already there in 2.4, I think. And let's talk a bit about the tools specific to ConstraintLayout.
So essentially, whenever you're in design mode and you're using ConstraintLayout, we've provided a bunch of different tools. One of the key ones is this inference, and I'll get to it. But we have a whole lot, and it's sort of like the kind of layout tools you see in PowerPoint, align left, align right, that sort of thing. And there's just a whole bunch of them. And here you'll see an example where I select a bunch of them, I make them into a chain, and then I select a subset of those, and I say left align those. And then for this one, I manually drag and create it. So it can work sort of interactively with making constraints by hand, and take a little time to get to know some of those tools, because they really help you move quickly when you're dealing with long collections of widgets.
I mean, imagine doing that in XML. So.
Yeah, if you had to what I just drew, if you had to write that in XML, you'd have just typed about 40 lines of code. So now, one of the other things that we're pretty happy about, and it may or may not have bugs depending on if you're using alpha versions of our stuff, is the inference engine. What we do here is we try to understand the layout that you have. So if you lay out things, and if you lay them out precisely, we will try to understand the layout and try and infer what are the constraints, and we'll put them in for you. So here you see it created all the constraints, it changed some of the things, different modes, and it all did it for you. It's a couple of important points about it. It's not going to try and beautify or realign all your widgets. So a lot of people have tried, I've seen people doing this, they try and put stuff in a sloppy position, and then it comes up with an inference that is sloppy. Well, I can't help it. That's what you gave me as a UI to infer. So it requires, it's for some sets of people who would like to spend their time just laying out precisely and then letting the tool do it. But there are a couple of other ways that it can work. If you have just a couple of widgets that are left at the end that aren't constrained properly, hit infer, it will find those widgets and it will add the constraints. It will not take away your constraints. So it's a great add-on tool, and it was suggested even to always press infer before you save and run your program, because it'll help fix, I forgot to add a constraint here or there. So when we're talking about animation now, there are quite a few types of animation we could be dealing with. One of them is view state change animation. Another is vector drawables, reveal animations, ripple animations. So there are a bunch of different kinds of animation that you can talk about, and I'll show a couple of different examples. So here is your basic animated icon. a kind of fairly trivial one, and actually it was one of the first I ever implemented myself. Pretty. But you notice that it's conveying a piece of information to you that is this is a menu, and now it's back there. And it does that with a little motion, so it's actually capturing your attention a little bit to let you know if something happened in that corner. It's pretty important to be able to do that when you're making user interfaces, so people don't get lost in your navigation. You can combine a vector drawable animation with a bunch of other animations. Here you see a view moving, you see a ripple, there's a bunch of different effects. And it all can come together fairly seamlessly and just have a cool look to it. These are straight off the material design website. So another kind of animation is the activity transition. This one is where you have two activities and you need to transition between one and another. And normally what just happens is one app just dies and the other app just comes up. But if you know how to use this, and if you learn how to do it, you can capture a view or an image, something from one of the previous activity, and sort of morph it into the next activity seamlessly. So it looks like the content just sort of flowed from one to the other. When done really well, this can produce a very sensational effect. And you can see on the sheet here, you could tell this guy is now here. It sort of flows the information and the user from one activity to another very seamlessly.
Actually, just very quickly. So the last part of the puzzle for motion on Android is layout transitions, right? So we talked about when you have some content that wants to animate, and that's vector drawable, that's this type of animation. If you have multiple activities and you are going from one to another, that's the activity transition. And there is the last part, which is, okay, I've got some type of layout, the way widgets are positioned, and I want to animate that. And that's basically done for free for you in the Android framework by Transition Manager. If you simply do a layout and you call Transition Manager, it will automatically do the animation for you. More interestingly, you can actually provide custom transition sets. So you can actually completely control how the elements are going to be animated and moved into place, and you control the endpoint by the layout. And we'll cover that a little bit later. And constraint set, it's kind of this really nice thing we added in ConstraintLayout. The first key insight is that we're trying to separate the views, that the view hierarchy that you have, all the elements you have on screen that you want to show, like the buttons, the text view, and all of that, and how we lay out them. And traditionally on Android, all of that is in the same place. You have view groups that basically gives you all the rules on how to position those elements, and you got views that, are displayed. And if we can separate them, if we can really have a distinction between the rules that decide where things are and the things themselves, you can do pretty powerful things. So constraint set is a way for us to encapsulate all those different constraints, those rules, to encapsulate them into a single object. And you can apply such object to constraint layout. But what's really nice is that, of course, you can use more than one constraint set object, and you can toggle between them, you can apply them, and etc.
Yeah, so this is a very simple example, and we create two constraint sets. In the first one, we clone, so basically we're copying the contents of that layout into the constraint set. And we then also set that constraint sets on the screen. Then we go find the other layout, and without even inflating it in the traditional sense, we create a copy of that constraint set. So the nice thing about this is I've now just captured two, you can imagine, layouts in system. I have two captured layouts. I'm now can use them whenever I want to switch between the two of them. And to switch, you just take constraint set and apply it to a layout. So it's very, very simple. It's an easy way to give you different kinds of states. So in this particular case, we have a dialog with a layout, and we have a landscape version. So we have two different layouts. We can capture them as constraint sets, and then when we do the rotation, the normal approach is where it tears down the entire thing and reinflates the whole thing. But if you override and say, I'll take care of it, you can just apply a constraint set. And nothing gets reinflated, nothing got torn down, all the layout, all the views are still live and in control. And so you don't have to do as much state managing of well, how do I recover my state and all that kind of stuff. It's just a quick change in layout. You're just moving all the widgets around.
If you have constraint set, as I said, you can basically encapsulate the state of your layout into it, and you can just just switch to them and use the transition manager to do simple motion, right? So this example here just does that. And what do you need to do? Well, basically you just add that one line. That's all. That's really, really all. And then the system will figure it out for you. You can also apply things at the individual level. In that example, I'm changing the parameters, the constraints on one of those elements, the one the finger is upon, and automatically, because it's a constraint, it's actually a chain here, it will all flow and do the right behavior. And to do that, it's really easy. Get the child, set the minimum height, and that's all. So the point of all of that is that we talked about flat hierarchy, and there is definitely an impact with performances, but another impact is about animation. You don't have problems with clipping anymore, because it's all at the same level. You don't have to find a view that is really deep down in the hierarchy and move it at a completely different level. And you can think about it as it's a scene graph. If some of you have experience, writing games and stuff like that, or 3D visualizer and things, it's a scene graph. It's just the graph of objects that you want to display on your screen. And you control their position with the constraints. So you can think about constraint set as, in terms of animation, in terms of motion, as a keyframe in an animation. And here is an example, right? If I want to have a bottom dialog like that, I can just do something like this. And this is simply two constraint sets, two different layouts. All the animation is provided for free. What you're not seeing here is that to build that, I just used the designer. So I was able to very quickly set the different properties, the attributes, and see if it was working or not. And pushing it on your phone, you can just see and try it. So one thing you can think of too is that constraint layout, sure, it's moving your views around, right? It's deciding where your widgets are. But it's not limited to that. Or more exactly, what we call components in general, they are views. So you could think about moving those views instead. And then you can think about it as just managing the entire state of your UI, not purely, hey, I have a dialog, I want to display something in that dialog, and let me put that button to the right of that text field. You can actually move around entire components. You still have everything that you have, with the constraints and the transitions and all of that, but now you do it at a slightly higher level. Still very flexible, and it's a lot easier to build and to test than other solutions. So here's an example. You might know navigation view, which is the view that you're using to do in draw layout to pull up the menu on the side. And draw layout basically handles the interaction for you. It's going to capture the touch event, pull up the menu, and you can ask it to close the menu and all of that. But it's something you can actually very easily do with ConstraintLayout too. Here, the only modification I did was to create a subclass, intercept the touch event, the swipe gesture, and just change the constraint set I was using. And I still use the framework navigation view. I didn't create my own view, but basically you get the same behaviors. So you may wonder why to do that, if after all DrawLayout does it. Well, all the existing components that the framework provides, they work well. But all they do is implementing what they're implemented for. They are not going to be able easily to be tweaked to implement other type of motion, other type of behaviors. While here, we are kind of redefining the motion and the behavior from the first principles. So, sure, I can use navigation view. But if you want to create a completely different type of menu, it's absolutely trivial as well. And here, this is just a menu created with ConstraintLayout. I did it in a few minutes in the editor. It's really easy to play with. Finally, we talked about the transition and how the transition basically does everything for you. So that's an example, right? We have two layouts expressed as constraint set, as we did before. And if I switch to the second constraint set, things are moving around. The only problem with that is it's a little stale as an animation. But those are just the default animation. And it's actually very easy to create your own.
Yeah, so the key here is that I've just, in the same begin delay transition call, I've added a new custom animation set. And in that custom animator, I've sort of plugged in the new physics engine to handle what happens at the end of the transition. So give it a little bounce. This can be programmed to do anything that you want during that animation, during that transition. So what you've done here is you do both layouts, both scenes with a sort of keyframes, and now you can customize programmatically the animation going between the two scenes, so that you're not just limited to whatever the sort of static, sort of dry animations. Now this is over the top, obviously. I mean, no one would ever say do it this way. And I have even crazier versions of this one, which flip around and stuff. But you can sort of see the shadows are moving nicely. They raise and lower, and all of these different effects. We just stood there with the person who wrote the physics animation. We stood and we just wrote all of the different effects and changed them and tweaked them until we were happy. And so, well, that looks nice. It's a good demo.
It's just a few lines.
Yeah. So it's very easy to build out these. We will eventually release source code for some of these things, but we're busy.
And that's another example of how you can customize those transitions from the transition manager. So what we saw before was basically intercepting the bounce of a view and deciding to, well, actually, I just want a spring-like effect. But you can do that too with visibility. And you have this ripple animation that the framework actually provides that you can use, but you have to use it in code and etc. What I did in that example is simply create my own transition set and just start the ripple animation. And that's really nice because it's the same effect, of course, but no, it's completely toolable. I just need to specify things in XML, decide their visibility, and that's it. So that's kind of the gist of what we are trying to achieve, I believe, is that the more, the type of coding that is not particularly creative and that's really repetitive, but you need to do in order to do those animation, I think would be much better if we could specify that declaratively. If it was set in XML, that means we could build great tools for them, and you could spend time actually doing more interesting work. So That's kind of the general idea. A little bit about what's the next steps on our end. We are right now working on Android Studio 2.4. If you try to use RTL support in the editor in 2.3, was not exactly there for ConstraintLayout. And so while ConstraintLayout itself supports it, we're working on making it a lot better. Componentry, we are improving it as well. And I'll go through some of the new features in ConstraintLayout. So the componentry, one notable difference is that we finally surface in the componentry errors and all those lint checks that you have that are not that easy to figure out where they come from. No, it's very easy. And one of the really nice, let's call it an experiment for now. It's the slice editor. So we talked about a little bit about the inspector, right? That's what allows you to change those attributes for those views. You may know or not that there is a second inspector that's hidden. If you click on that button with the two arrows on the top right corner, well, you got that thing. And that stuff basically is showing all the different attributes that are possible. While you can search, it's not an amazing user experience. And so the slice editor looks like that. And if you are used to XML, it may look familiar, and that's kind of on purpose. So the idea here is that we show you something that looks kind of the XML. You actually still have auto-completion and things like that, with one interesting twist.
Okay, I like to explain this. So what you're seeing on the right is all the lines that affect the selected object across the files that are affecting it. So the selected widget, its view parameters, the underlying DIMS object that sets some dimensions, and the IC launcher coming from another directory. So it's essentially slicing across all your files and showing you everything that's related to your current view. So normally you say, oh, that's in a DIMS and that's in this file, and I have to go change that file to get it to affect it. You see across all three of them. In this particular case, it's 3. And if there were 10 of them, it'd be all 10 of them would show up there.
Yeah, and so the idea is that you'll be able to not only, I think it's a better visualization than even the XML, because it shows you only what actually matters to you. So it's definitely for experts, right? If you know your attributes, you know your XML, but you want to see what's going on, I think it's a really nice, at least it's a new feature. We are more than eager to hear what you think about it. If you download 2.4, I think you should be able to trigger it. It might still be broken a little bit, but give it a try, and by all means, give us feedback. A little thing about barriers in ConstraintLayout. You might have encountered these issues with ConstraintLayout where you want to basically do a position that depends on, let's say, here that's the position, but it could be like the width of an element. So you don't know which element is going to be, let's say, the widest, because languages change or the content, you don't control that. But you do want to set another element here on the right of those two elements. So without knowing which one is the widest would be really difficult. And barrier basically allows you to do that. It's kind of a min or max on a set of existing objects. So it's a bit of a corner case, but in some situation that's definitely really useful. We also are going to introduce groups, which is, think about it more as a shortcut. You could totally do that programmatically. In fact, if you're using group, you probably want to do that from Java. But instead of having to maintain yourself a list of the objects you're interested in, you could basically specify that in XML, which can be very convenient. And the idea is that if you set an attribute on a group, all the elements inside that group will receive that attribute. So it's a shortcut. And I should have completed my slide a little bit more, but one of the things we added recently, I don't remember when, but was a more complex behavior on match constraint. The default behavior on match constraint on a widget is to spread. You collect it on the left and the right of your parent, it's going to take the size of your parent, minus margins. But you can actually specify and change the default behavior. So you can have a default behavior that's more behaving like wrap content. The difference with wrap content is that it will actually not grow beyond the constraint you specify. And one extra behavior we are going to add in 1.1 is the ability of defining that dimension as a percentage of the parent, which is just another way of doing what you could do today with guidelines, but in some situation it comes in handy. And that's it for the talk.